Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Bilal Muhyiddin and now I will tell you one of IoT project in IDN boarding school Sentul. It is smart watering plant. Okay, so for the first, what is smart watering plant? So for the short explanation is an automatic irrigation system. Okay, for the long explanation is smart watering plant is an automatic irrigation system that waters plant based on soil moisture or preset schedule. It typically uses a soil moisture sensor, a microcontroller for the brain. We usually use a microbit and a water pump or solenoid valve to deliver the water to the plant. Okay, so how it works? So when the sensor detects that the soil is dry, the microcontroller or the brain activates the pump, and the pump will watering the plant automatically without human intervention. Interfe- intervention. Intervention. Okay. So what is the purpose of this project? So for the first, it is save water because the project will watering the plant only when the soil is dry. So if the sensor didn't detect the soil is dry, the pump will not give any water. The second is save time because this project is we can monitoring it by online, so we don't need to check it every time, every day, every week. The third is maintain optimal. Same the it is the same reason with save time because we can maintain it with our handphone or any device. So yeah, we will maintain it by optimal. Optimal. The fourth is support smart home automation, and the fifth is improve energy efficiency by operating only when needed. Okay, so maybe that is for the purpose. For the advantage, the first is time saving. It is same like the purpose. The second is water only when the soil moisture is below a threshold. Okay, this the same like the purpose. And the third is scalable because we can custom it. We can custom the size, so we can handle multiple plants or a large garden. And the fourth is IoT integration. Same as like I said before, we can maintain it by online. So yeah, we will integration it the project and the device. And for the application, we usually use the Blink. And the fifth is environmentally friendly because this project is reduce water waste and energy use. Okay, so for the next is disadvantage because this is IoT. It means Internet of Things. So this project is internet dependency. It means requires electricity and the internet and anything else. And the second, sensor maintenance. The sensor, uh, sometimes the sensor may need cleaning or replacement. We can change it with a better sensor or anything else. And of course, if we need a sensor, we will cost the for the sensor. We will buy it. So uh, the disadvantage is we need a money. And for the fourth is sensor noise. If you buy a cheap sensor, usually the sensor is not accurate, or for the first it's stable, and for maybe after a week it will unstable. So I provide you to use a standard sensor. Okay, so for the platform from the for for the coding, there is two platform. For the first is MakeCode. Uh, MakeCode is a platform for we code the microbit that the controller we usually use. So for the explanation is Microsoft MakeCode is a free web-based coding platform developed by Microsoft. It allows users, especially students, beginners, and hobbyists, to create programs directly in a web browser without needing to install a software. So MakeCode is designed to make programming simply and fun by combining block-based coding. So we coding it by based on blocks. Did it, we don't need to coding like you must typing it. No, we use a combining block, and yeah, this is for the explanation. For the next, the second platform is Arduino IDE, or for the IDE is Integrated Development Environment. It's a free open source program used to write, compile, and upload code to Arduino and compatible microcontroller board. It supports C++ programming with a simple interface, making it easy for beginners to create projects like IoT device, robotic, and smart system. Okay, so for the tools, there is 10 tools we usually use. For the first is microcontroller, of course, because it is the brain of the system. And for the microcontroller, as I said before, we usually use the microbit. And the second is soil moisture for detect the moisture level of the soil. So it is the main sensor of this project. And the third is relay module. It is acts as a switch to control the water pump or solenoid valve. So it is for the like the switch to turn on the pump and turn off the pump. Okay, because we wanna give the plant a water, so of course we need a pump to watering the water to the plant. And the fifth is power supply. For this project, we need a 12 volt. So you can search it in online, adapter 12 volt. And the sixth is water tubing or pipe. It's for deliver the water to the plant. Okay, so the seventh is jumper, or we can say cable. The cable. It is for the connecting all of the components that we use. So it is also the important tool. And for the breadboard is optional because it is only for make your project tidy. So if you don't want to buy it or use it, it can work actually. But I prefer you to use it because it uh, makes you easier to make the project. And the ninth is resistor. It we can say protect your component. If the fault is too high, the resistor will protect your component. And wiper router is the last, and it is also optional because um, if you don't want to use it, the project will go normally. Okay, so for the last, it is the code example. I will explain you one by one. So for the first in here, there's on start. So for the short explanation, this code uh, for the integration to the application that is Blink. So this is for the ESP 8266 initialized, and it's for the Wi-Fi connection. And if it didn't connect to the device, it will show some icon. Okay, so for the under the Blink integration, there is LCD initialize is for LCD. Oh yeah, LCD is optional. So if you don't want to use it, it's okay. And this for the temperature, the temperature, the soil temperature. Okay, so this is the some of the functions. That is for the pump and pump blink. Okay, so this code is for the pump. So when soil detects more than 900, the pump will on. And the pump, if under 900, it will turn off the pump. And for under this code, it is for deliver the data from the project to the device. So this code is for taking the data, and from this code, it will integration it first with the device, and after that, if the sensor detects some detects the soil, the data will give to the device. Okay, so this is for the LCD code. I will not explain it because it is optional. And there is DS and soil. DS DS sensor and soil sensor is a same sensor, but yeah, it is the same sensor. Okay, and this is for the same. This it is the for the LCD code. Okay, and the last is forever. It is for all of the function that we use. So this code will repeat the code forever. Okay, maybe